Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will show that the series in front of us, it's gonna converge and we will find its sum. And the technique that I will be using is partial fraction decomposition. So this will help me with integral and it will help me with series, that technique. So my series is sum n equal 1 to infinity of 1 divided by n times n plus 1. So if I take 1 divided by n times n plus 1 and I do the partial fraction decomposition, since both n's that I have, this n and this n, is to the power of 1, so I can put a divided by n plus b divided by n plus 1. And now I want to have a common denominator on the right hand side of my equality. So the common denominator is n times n plus 1, and here I can write it n plus 1. And then I will I will add the fraction, so I will have a times n plus 1 plus b times n, and I will, since I have the same denominator on the right hand side and the left hand side, I can take out the denominator, so I will have 1 equal an plus a plus bn. I multiplied a by the parentheses, and now I have an and bn. I have n in common, so I can factor it out. I have 1 equal a plus b times n plus a. So on the left hand side, I don't have any n on the left hand side, but on the right hand side I have a plus b with a coefficient of n, so that means my a plus b is equal to 0. And on the right hand side I have a that does not have any coefficient of n, and 1 does not have any coefficient of n, so my a is equal to 1. That means since a plus b is equal to 0, my b is equal to minus 1. So I can rewrite my fraction, the series n equal 1 to infinity, instead of saying this, I can write it like this, because it is a, and we said a is equal 1 divided by n, and b is equal minus 1 divided by n times n plus 1. And that's my decomposition of my fraction. I decompose it like that, and now I replaced a and b by its values. So now if I take few terms and replace n by the first few terms, I realize when n is equal to 1, that would be equal 1 divided by 1, because n is 1, minus 1 divided, 1 plus 1 is, no, here there is no n. My b here did not have any n. So that's my b and that's my a. I have to put it exactly the same thing. And when n is equal to 1, I will have 1 divided by 1, because 1 and n here, minus 1 divided by 2. And when n equal to 2, I have 1 divided by 2 plus 1 divided by 3, minus 1 divided by 3. So I replace n by 2 here and n by 2 here. And when n is equal to 4, I will have plus 1 divided by 4 minus 1. When n equal to 3, I would have 1 divided by 3 minus 1 divided by 4. And the last one, when n equal to 4, I will have plus 1 divided by 4 minus 1 divided by 5. And the last term is going to be 1 divided by n plus 1. So I realize that I have plus 1/2, minus 1/2, plus 1/3, minus 1/3, plus 1/4, minus 1/4, and etc., etc. So the sum of my series would become this one, and all the terms in the middle is gonna be equal to 0, because I have plus and minus the same term. So my sum n equal 1 to infinity is equal to 1 and minus 1 over n plus 1. So if I want to find the sum, I have to find the limit when n goes to infinity of 1 minus 1 divided by n plus 1, that's a plus 1 here. So when n goes to infinity, that goes to 0, because 1 divided by infinity is equal to 0. So my series converge toward 1, because I would have the limit when n goes to infinity, my series is equal to 1. So the series converge, and its sum is equal to 1. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.